Hello, this is my last video in this series on transaction basics, transaction types, and this one is about transaction examples in Java. So in order to save some time, I already did some programming. So what I did, I created a new simple console project like this, and I created a DB connector, which is just a simple class holding my database connection data. I created my main method here where I can actually run stuff. And I created just a simple business entity or POJO or whatever you want to name this called an account where we have different things like we have an ID on the account, we have a name of the person holding the account, and we have a balance. And also these are the same data I have in my database, which is a Microsoft SQL Server. And this is why I'm also importing the SQL Server Exception here. And I also use some, I just downloaded the driver using Maven from within IntelliJ, but of course, you need to download whatever driver you're working with. I'm working with Java 14 here. So, and using the driver, Microsoft JDBC driver for version 11, I think it is. It works with the version 14. Okay, so I talked previously on the different transaction isolation levels here. And first off, what I want to do, I created a very simple program where I have a list of accounts in my database. You can see the list here. These are data directly from my database. I have some persons in here, 10 persons, and these 10 persons have some money in their accounts, which are like randomized. And randomized names as well. So what I did first, I created a couple of methods here. I created one called load accounts, which will just load the accounts into my program. And I also created one called list accounts, so I can easily just list the accounts like this. So all it does really is if I press play, it will list the accounts like that. So that's it. So now I have a list of the different accounts and whatever balance they have, each of them. So first off, I want to show the problems that can occur. So you can easily imagine this is a banking application or something like that. And let's say that we have two systems trying at once to access the same person's data. So let's take this one, Nicole, which I, for convenience, just set the balance to 0. So let's say that this person can have minus balance on her account or his account. So this person could have something like a minus 1,000 or something. No problems. They have some kind of appointment with the bank. That is okay. So what I did then is I did something which might be a little convoluted to you if you haven't looked at threads before, although it is very simple. I can briefly explain what's going on. So what I did, I created, first off, I set a test account. So the account that I actually want to test on, I'm setting get 0 because this is the first one in the list here. Then I print out which account it is I'm testing. I print that out to the screen. And then I use something called a countdown latch, which is a very crude and not very good way, but it works for this purpose to count when the threads that I'm creating are done working. Because I want to simulate that I'm doing two things at the same time, I cannot run this in the same thread. So basically what I do, I define two threads here, the one called transaction 1 thread and the other one called transaction 2 thread. And what they do is I just specify what they should do whenever I start my threads. And what I specify is that they run a method called withdraw, which will withdraw money from the bank. And then it prints out that it has been done with its work. And then it also does this latch countdown, which counts down this latch so that I can actually wait in my main thread until the two sub threads have finished their work. So basically, the program runs until starting the two threads, and then it waits until the two threads are finished. And they will start at almost exactly the same time, within milliseconds. It will be very fast to start up these threads. Sorry. So they will start at almost exactly the same time. We'll just assume they'll start at the same time. So what I did with my withdraw method is that what you can see I'm doing here is I'm creating a connection to the database. Then I'm selecting the amount from accounts where the ID is equal to something. And amount is the amount of money that's actually in that person's bank account. Probably should have called it balance. It is the same thing. I'm sorry about that confusion. I didn't see that before now, but basically it's the balance on the person. You can also see here I'm fetching the amount and putting it into the balance. So I'm selecting the balance or the amount from the accounts where the ID is equal to whatever account I put here. So in this case, I put 0, so it will be Nicole here that I'm getting out. Then I create a prepared statement, and I set the account ID to replace the question mark, and I run the query. That means that now my result set here will hold this row here. Or not the row really, but just the amount from this person here, which is 0.0. And then it runs through, it checks to see if there is any result. Normally you would put while here, but in this case I'll put if because I only want one result. And I'm going to say if there's a result, do this, otherwise it will just return null, I think. Yeah, that is probably, should I have something like return null here? Oh, it's void, sorry. So it doesn't return anything, it just doesn't update the accounts. So the next thing is if we do have something in here, it actually fetches the balance from the result set, which we fetch from the database, and then it calculates the new balance. So it takes and calculates what should the new balance be, and then it waits for a while. And normally you wouldn't do this, like waiting time within database connection is bad, but this really simulates that it could take some time for this to happen. If you have a slow internet connection, if you have, for example, on a cellular or something like that, it could actually take some time. So I sleep for some milliseconds, which I define up here as a parameter, so I can use that to simulate that there is some waiting time in between calculating the balance and updating the balance. So the next thing here, the only thing that does is just going in and updating the balance and setting that in the database. And after setting it in the database, it also sets that object in memory so that that everything is aligned so that the database and the memory object, the account object is the same. And if we have any exceptions, we crash and burn. I haven't gone too much into that here. And also it has this interrupted exception because when we use thread sleep, we can get something called an interrupted exception. So we need to handle that. So that's why we are doing this. So basically withdraw, it takes any account, it calculates the new balance and it updates that balance on the account. And the problem lies here that you can see this statement is one part of a transaction and this statement is another part. This one reads from the database, it reads the 0.0. Then if I put in, let's say 300, it should be, the new balance should be minus 300 and then it updates the balance to minus 300 here. So what we could do is we could try to withdraw two balances at the same time, simulating, for example, one person goes to an ATM, the other one goes to a shop, and they're using money at the same time. So let's try to simulate that. So the way we can do this with this small program here is that I can set the sleepy time differently. So they will start at the same time. They will actually read from the database almost at the same time, but they will actually sleep in different times here. So they will basically read the same amount, and use that for calculating the new balance. So let's see how that works. So I set the first one, I set this to 300, and I set the second one to 800. So we're imagining that we have two transactions. Let's say one person is me going to the ATM to get some cash for going to the casino or whatever. And that I'm on a slow ATM for some reason. This takes 1 second to actually, after getting the actual amount, it does take 1 second for me to move on. And the other transaction, my wife goes out to buy new shoes or something like that, getting her nails done, I don't know. And it, this is a bit faster. It takes only 200 milliseconds, but it kind of gets started at the same point in time. So it means they will start at the same time, and then one of them will halt for some time, and the other one will halt for a shorter time. And let's see what happens then. So what will happen here is if I press play on this, I first print the actual, and we can see that Nicole Iakovone here is having 0.0 dollars in the account. Let's imagine that's me. And then we can see now thread 1 is done and then thread 0 was done. And that's because the first thread, thread 1 is this one, so it finishes a bit faster than this one. So what happens next is that we can see now the account balance is minus 300. So the problem here lies that the first person actually retrieved 300 and the second one 800, and then the database actually only updated this 300 because it didn't see that this person actually updated it in the meantime. So what happens is this person reads that there is 0 on the account, then calculates, and then the new balance must be minus 300. But while it's doing that, this one is actually going in, also seeing the 0 on the account, saying now the account is minus 800, and this one doesn't read the database again to see that it actually changed in the meantime. So that is why it will just override with whatever the slowest one is. And this is of course a big problem for the bank. So how can we fix this? So this is actually something which is a dirty read, right? Where we're reading something from another thread, or let's go in here. So we could call it a dirty read. A dirty read is something where it can read from a row that has been modified by another running transaction and not yet committed. So although we're not using real transaction, it is somewhat similar to that, or we could also say non-repeatable if we were actually to read it again. But in our case, it's more like a dirty read. So what do we need to do to stop this situation from happening? Of course, the answer is we need to do a transaction. We need to say that the first transaction here is one transaction and the other one is another transaction, and we need to set the right transaction isolation level. And because we know this is a dirty read, we can look it up in our table. What we're doing now is actually transaction read uncommitted, which is we're just committing everything as we go along. And the next one is called transaction read committed, and these will actually prevent dirty reads by blocking the database while it's being updated. So let's try to change into some code that will actually prevent the dirty reads. As I explained in my last video, you shouldn't go above what you need for this example. So we know what the problem is, and we'll just go for transaction read committed in this case. So if we go back to our example, we need to change our code a bit, and the problem is not really these people here that are doing stuff, but the problem is this withdraw method here. We need to put some more stuff in here for this to work. So the first thing I'm going to do, I'm going to enable transactions. And the way we can enable transactions is that we're going to take the connection and then we're going to do something that is called, that is, I think, not a very good way they implemented that, but you need to use the one called set auto commit. You need to set that to false. So I don't know. I'm not sure this, but auto commit means that it's because JDBC by default is actually doing transactions, but it's just doing transactions on transaction read uncommitted. So whenever you go in here, whenever you say like execute update, it will, let me show you, it will actually say, sorry, commit on this transaction here. So I cannot do that. I'll show later why. But so the first thing we're going to do is we're going to set the, yeah, I better explain that. Okay, so we set the, of course, we set the commit on the connection because we cannot set it on the statement. So whenever we set auto commit up here to false, it means that anything we do like execute query and execute update and all of these database operations are becoming one transaction because this is an atomic operation, this is an atomic operation. So now we have put two atomic operations inside of here, and we need to commit that when we're doing transaction for that to work. The other thing, this is enable transactions. Another thing we need to do is we need to set the transaction isolation level. Set transaction isolation level. And the transaction isolation level that we wanted was the one called transaction read committed, and we need to import that. So I just imported that probably up here. Yeah, Java SQL. So Java SQL transaction read committed. So now we know that this is should prevent the dirty reads that we actually want to prevent because we saw the dirty read in action here. So the next thing is we're doing the same thing, but now instead of really executing the query here, it's not really executing the query. It's actually waiting to execute the query for real until everything is done, until I actually commit on the connection. So what I need to do is that after executing the update, I have done both this and I've done this. So after here, I need to say connection dot commit. This will actually commit both statements in the database. And while we're waiting for these two to commit, it will actually need to lock down that part of the database so that no one else can go in there and try to fiddle around with that. The last thing that we need to do is that because we have now changed our connection here and I reuse this connection between databases, it's always good practice after finishing to actually set back the connection to whatever state it had before. So I set auto commit back to true, and I set the set transaction isolation level back to I think there is one called transaction none. Yeah, like that. So I'm actually putting it back in the same state as I got it. I could even get the auto commit and save it up here, so I'm sure I'm not. But at least you should go back to some state. So unless you want to set this permanently or something like that. So I'm just setting it back here. So now that I've actually done that, I'm I should be able to do these two threads now. So let's try and see what happens now, because the only thing I did was I put them into a transaction, and they are waiting inside of that transaction for some amount of time. Okay, so what happened here? So what I can see now is that I had exactly the same thing happening. So what happened here? So let's go back a bit and try to see what the problem is. So the problem really is that I wasn't completely honest before. So now I set my transaction to read committed. What we should have seen if this was actually a dirty read is that we would have something like a SQL exception or something like that, saying that you cannot try to do a transaction here. You have to handle this exception. So let's just try to go back here and look at Wikipedia. So what it says is, it says it's an uncommitted dependency. So what we can see here is that this hasn't been committed yet. It's rolling back. But what we are actually doing in here is that we are actually committing the change in between the two different transactions, because while one of them is waiting to commit, the other one is has already read something that was committed. So what we're really looking at here is more a non-repeatable read, where we have done a commit in between and not looking at uncommitted data like this. So it's more like we have two commits like that. So what we should do then is we should say, okay, so there's some problem with the transaction isolation level. Let's try and see what the next one is. So we can see that dirty reads, non-repeatable reads. So if we want to have non-repeatable reads, we should use transaction repeatable read. So I put transaction repeatable read here, and now we should be able to see some problems. Let's try again. And now the system will hang and wait for a second. And then we can see that we get a severe error here in our withdraw method. So now it actually says there's a SQL Server exception saying transaction of process ID 54 was deadlocked on locked resources with another process that has been chosen as the deadlock victim. Oh no, we've been a victim. Rerun the transaction. So what it actually says here is that if we look in this line, we can see this is the line that where it tries to execute the update. After been sleeping for 2 seconds, it tries to execute an update on something that has been changed in between. So because the first part, the execute query part, is not producing the same result, if we tried it again, we actually get an error here. So, and we can also see this comes from this lambda expression here. So this is, oh, it wasn't 2 seconds, sorry. After sleeping for 1 second, we get a problem here in the execute update that we cannot update because someone else is in there. So the way to handle that is, of course, that we go for here SQL Server Exception instead of logging it as I'm doing here. We should, of course, try to redo the entire, what's it called, the entire transaction. So we could do something in here, like we could say withdraw, and then we could put the same data in here, account, and then we could use the amount and also the sleepy time. And of course, this would mean that every time it would fail, it would just start over. So one of the other things we could do, we could set a sleep in here, like thread sleep, and we could use the same sleepy time, or we could just define, try to wait for like 400 milliseconds, and then it tries it again. And we could also have something here like if you tried it already like 5 times, give an error message or something. So if we run something like this, it will try and fail, and then it will try again, and then it finishes. And we can now see we started off with 1400, and the first time we tried the transaction, it went south, right? And the second time it actually went through. So now we went from 1400 to minus 2500, and that is, let's see how much it should have been. So let's go up here. So 300 plus 800 is 1100, and there's actually 1100 in difference between these two balances here. So this way we are kind of calling the method itself. Of course, you could get a Stack Overflow theoretically if you kept calling within itself. So I definitely think you should have some kind of limitation here. Maybe you should have something called, could also have something here like end and then retries. No, retries. Yeah, it is with an I. And then you could say, okay, the amount of retries. Then you could do like here, you could say retries -1. And then you could say if retries is bigger than 0, then withdraw. Otherwise, you wouldn't actually go any further with this. And maybe you should even put the sleep part in here so you wouldn't sleep if you don't have to. So let's go for this. And then you have to, of course, I need to set the retries. So let's say I want to retry 3 times for each of them, and it should still work then. Yeah. And if we do something then, let's say that it's trying, let's say that this one, let's go for 5 seconds on this one, and then go for 200 milliseconds on this one. And how much time did we sleep? Like 400? Let's go for, yeah. Let's say we're going to sleep for half a second between each retry, and then let's try again. So we go here, we get the error, and the thread is done, and then we go through. So we just get a little extra waiting time. And we could also, let's try to change this into, yeah, something like that. So yeah, I don't think I'm going to elaborate more on that. But the interesting thing here is that we can put retries in like this, and we have to handle it using the server exception. And I even think we could go and look at which kind of exception this is. So if we look into, we have access here to the SQL Server. We could get the SQL Server error. Let's try to say this out. If we print out the SQL Server error here, let's see if we can do that. We can see that we get a SQL Server error. Okay, that's just an object. So let's try get error number, for example. We could use that. And then we could check to see if that error number was equal to something. And then if we can see that it's a transaction error, we should retry. And we could even have multiple of these with an if sentence, like if we get this kind of error, retry. If we get this one, retry. If we get this one, then just fail immediately. So based on which kind of error we get back from the database, we would want to do that. Should be aware though that this gets SQL Server error and SQL Server exception is coming from up here, from the Microsoft JDBC driver. So based on which kind of database you have, you need different kinds of exception handling. So if you're doing exception handling like this, you'll be very tied up to the driver that you're actually using here. If other drivers doesn't have the same numbers, and they probably won't, then you won't be able to do as much of a specialized error handling as I'm talking about here. But I think that's out of scope for this here. So what is important when you're working with transactions? So first off, you must be sure which kind of transaction isolation level. I made the mistake first time to go only for read committed because I was thinking initially that I was just talking about dirty reads, but I didn't read entirely that we were talking about things that weren't really, hasn't been committed yet. But we were really talking about when we read the same um, value twice, that the second time it's actually different from the first time. So by setting the correct transaction isolation level, I was able to actually get the errors, and I was able to gracefully try to handle that error just by retrying a couple of times to see if we could actually get that up and working. So that's basically it for me with transactions. I think you can go to I have some examples on my GitHub page, more elaborate examples where I use transaction handling also in graphical systems, but I just wanted to keep this very simple, so that it's much easier for you to focus on the transaction part. I know it was a bit maybe messy with this thread thing that I have here, but try not to worry about it. Basically, I'm just timing it here with these two withdrawal methods, so that they will run at the same time and interfere with each other. So thanks for watching.